Morning, everyone. Welcome back to another exciting day in mathematics. Woo, woo. Warm-up number 19 is on the screen. Shouldn't take you long. Number 1, 2 should be a review. Same thing with 3 and 5. Number 4, if you notice, I introduced a new equation on number 4, but I'm pretty sure you should be able to solve that. Let's see how you do with that. Yes, Mario? Yes, you're an advisory. Be nice. Advisory, yes. Let me record that. It's being recorded. Yeah, for those of you that were absent on Friday, make sure you come see me during advisory tomorrow or Wednesday and take that pop part, okay? Yeah, because that's coming onto your grade pretty soon. All right? Get started. Go. Reminder, Wednesday is open house. Make sure you tell your parents to come in. We have, I'm going to try and get for them some waters, cookies, and Starbucks. Let me see which ones. Because some people came back. Gio, whose container is that? Is that yours? Okay, yeah, everything. Yeah. All right, being that it's Monday, and for the sake of time, I'm going to go over the warm-up myself. Here we go. Make some room. All right, so for number 1, look up. Do you see any addition or subtraction here? No, so we're going to multiply. However, look up. In order for me to multiply, I like to make sure that this is in standard form. That means from highest degree to lowest degree. So what is the degree of this term? 1. About this term? 3. About this term? 0. So I need to rewrite it. So I'm going to write it as 4x squared y, then plus 3y, then minus 2. And now I can multiply times 2x squared y. Is this one in standard form? No, I need to bring this one over here and this one over there. Minus y minus 1. We good? All right, here we go. I'm going to use distributive property. 4x squared y times 2x squared y. That's 8x to the 4th, y to the 2nd. Next, 4x squared y times negative y. That's negative 4x squared y to the 2nd. Next, 4x squared y times negative 1. That's negative 4x squared y. Whew. All right, let's go to the next one. 3y. What is 3y times 2x squared y? That's positive 6x squared y squared. 3y times negative y, that's negative 3y squared. And 3y times negative 1 is negative 3y. All right, not bad. And last but not least, negative 2. What is negative 2 times 2x squared y? Negative 4x squared y. What is negative 2 times negative y? Negative 2y. And what is negative 2 times negative 1? Positive 2. Ooh, that's a long one. All right, here we go. Is there another x to the 4th y squared? Let's see, x to the 4th y squared. No, let me bring that down. 8x to the 4th y squared. Next, Is there another x squared y squared? X squared y squared. X squared y squared, yes, right here. Is there another one? Nope. What is negative 4 plus 6? That's positive 2x squared y squared. Next, negative 4x squared y. Is there another x squared y? X squared y, yeah, right here. So that gives us negative 8x squared y. Let's continue. Is there another 3? This one is what? Negative 3 y squared. Is there another y squared? No. So negative 3y squared. And then we got negative 3 and negative 2y. That's negative 5y. And at the end, plus 2. Woo, that was a long one. Let's go. Hands if you got something like that, some of you? Yes? All right. Next, number 2. Distribute the negative in here, so that becomes positive 3x squared. That one is negative x, and that one is positive 1. So now I no longer use this, and I combine. Here we go. What is 1x squared and 3x squared? That's 4x squared. What is 5x minus 1x? That's positive 4x. And what is 6 plus 1? That is 7. Hands if you got that? Some of y'all? Okay. Number 3. Minus 5 minus 5 minus 5. That gives us, I'm going to write it over here, negative 30 greater than or equal to negative 5x greater than negative 40. But then we divide by negative 5, negative 5, negative 5. That leaves us with 6 less than or equal to x less than 8. And if we write that in solution set of x such that, and you close it. We doing good? Yeah? Let's go to number 4. Number 4, let me make some space here. Look up. All right. Let me pause the music in the back. Writing utensils down really quick. Let me go over this. Look up to the screen. We have an equation. To leave x by itself, we have multiplication and subtraction. Where do I start? What is the opposite of subtraction? Addition. So we do 25 to both sides. Hold on, don't copy it yet. Pay attention. 49x squared equals to 25. So now, what is the opposite of multiplication? Division. So we divide by 49, divide by 49, and we end up with x squared equals to 25 over 49. Are we there so far? Next, we need to get rid of the squared. How do we get rid of a squared? We take a square root. What do we do to one side? We do to the other side. X equals, what is square root of 25? Square root of 49. Copy that, please. And once again, some of you already saw this before. I'm just bringing it back just little by little because we're about to get into equations and functions, which are quadratics and polynomials. So copy that. All right. So number 4, good? Yes? All right, let's go to number 5. Last one. Greatest common factor of 18, 24, and 30. Tell your neighbor what would be the greatest common factor for 18, 24, and 30. 18, 24, and 30. Greatest common factor. Let's see. 1 times 18, 2 times 9, 3 times 6. Then they repeat. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Then they repeat. 1 times 30, 2 times 15, 3 times 10, 4 times nothing, 5 times 6, and then they repeat. Looks like the biggest one is it 6? Yeah? Is that the greatest one? Yeah, it looks like GCF is 6. All right. Do me a favor, send me your notes. Let's see what you do, what you wrote down, please. And as you're sending that in, once again, guys, some of you, they were pointing out that I made a mistake over here with the negatives and one negative and -2. So there's some that need to cancel out, but to avoid time, I'll hold on to that for right now. Those of you that are following on YouTube, make sure you double check that one more time. But I did that on purpose so that, see if everybody was paying attention. All right, copy the agenda, please, once you send that in. Warm-up number 19, multiplying polynomials. Today we're going to be looking at something called the Binomial Theorem. Binomial Theorem. And tonight's home plate, 8 problems for the Binomial Theorem only. Yes, sir? Oh, sorry. It's frozen. Let it go, let it go. Have you guys heard that song? All right, so warm-up 19, multiplying polynomials, and 8 problems for home plate tonight. Once again, don't fall behind, guys. Like I said, it's going to start snowballing little by little. The rigor is going to start incrementing as we move along. So stay focused. All right, copy this code for your access for your home plate. PLNXF. 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 All right. So the weekend I gave you guys a free pass, right? Since we had a pop party on Friday, let's go. Once again, those of you that were absent, make sure you come see me during advisory tomorrow or Wednesday to get that done, because that's going in the books as soon as your report cards are sent out. I'm not going to include that pop party yet. I'm going to include it after. However, before last Friday, I gave you guys some practice with identities that look like this. For today, they look like this. Look up. Look at that. How beautiful that looks. Let's go. All right. So get a Cornell note ready, please. It's going to go pretty fast, so stay focused, please. Okay. It reads, I can multiply polynomials. I can multiply polynomials. So let's see if you catch the pattern where we're going. 2 weeks ago, we started with polynomials. We gave classification, gave them names. Remember that? Set them in standard form. From there, we moved on to addition and subtraction. Is that correct? From there, we moved on to multiplication. Today's the last day on multiplication. So that means, what are we doing tomorrow and on? Tell your neighbor, what are we doing tomorrow and on? If we already covered addition, subtraction, and multiplication. Your favorites, right? Division of polynomials. Let's go. Oh yeah, we got this. Or in other words, who remembers factoring? That's one part of it. That's one part of it. All right, y'all ready? All right, here we go. Tell your neighbor the definition of polynomials. They should know one by now. One word. Definition of polynomials. Everyone. Expressions. Yes? All right, so we got that under our belt. And where we're going today is looking at patterns. Write your utensils down. Look up to the screen. Look up to the screen. Here it goes. So in the world, there's patterns, such as nature. Look at nature. Here's a shell. You guys, have you seen this shell right here? I have it over there on my stuff. Whenever you stop by, you can go look at the pattern. And it grows like this. Same thing with these flowers. Vegetables, they grow in the same way. Here goes the shell again. And it grows numerically, by the way. And that's not only embedded in nature, it's embedded in us. Look up. And if you notice, here's the little curve. You guys see that in red? It's the same curve as that. That's why now with technology, do you guys have your phones, right? Where you can actually turn it on or gain access with your thumbprint, right? because it has numbers, okay? So those kind of patterns, mathematicians throughout the years are figuring out that there's patterns to everything. And one of those patterns known as that one is known as the golden rule. We're not going to get into that right now because I don't want to freak you out. But I can tell you this, companies use mathematics embedded in our DNA to sell you stuff. That's why a lot of the things that you see at eye level or when you go to stores is specifically because they know they can sell you the product because of the math involved in it. We can get into that later just for the sake of time. So most of these numbers, guys, there's mathematicians that work with these numbers, like this one is known as the Fibonacci pattern. We'll talk about him later. But today we're going to talk about another one. His name is Pascal. He's a French mathematician, and he came up with a pattern for binomials, where we can multiply big binomials just by following a pattern. And the pattern he came up with, he called it a Pascal triangle. Look up to the screen, and it looks like this. If you notice, he started with 1, and on the edges, he kept adding 1 to the edges, but it keeps growing, but he needs to fill in the gap inside of the triangle. Look up. I'm going to put some animation with this, so writing utensils down, pay attention, you're going to miss it. Here it goes. Here it goes again. I'm showing you because you're going to create one right now. More time. Once again, this is known as the what? Pascal triangle. So now let me show you. Look up to the screen. When he starts with the number 1, he considers that row number 0, because that's the start. However, the very next row is considered row 1. The very next row is considered row 2. The very next row is considered row 3. The very next row is considered row 4. Now let me show you how to build it without doing the honeycombs like that. Watch. When I tell you, build me a Pascal triangle, this is what you're going to do. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Pretty straightforward? Yes? All right, so this is what I want you to do on your paper. Write Pascal triangle. Don't copy this one. Copy this, and then label it row 0, 1, 2, 3, and 4. Copy that. All right. So we got row 0. Yes? We got row 1. Yes? Row 2. Row 3. Row 4. Yes? Now, this is an easy way of identifying which row you're on. What number do you see on this one? Mostly. 1. How about this one? 2. This one. 3. 4. Well, guess what? Now that you know how to get the pattern, tell your neighbor, what would you write for row 5? Talk it over your neighbor. What would you write for row 5? Talk over your neighbor and fill that in, please. What would you write for row 5? Caitlin's got it. Very good, Caitlin. I see you. Sammy's got it. Oh, Mario's got this. Mario's got this. All right. Of course, Gio's got it. Very good. All right, so you filled out row 5. Fill it out, please, and then Gio's going to enlighten us with those numbers to make sure that you got the correct answer? All right, Gio, go. Uh-huh. Yes. 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 Woo! From the corner, let's go. Let's go. Hands, have you got that? All right. If that's true, show me row 6. Show row 6. Row 6. And then Gio's going to pass it to someone. Woo-hoo. Yeah, Gio's going to pass that one. Favorite receiver. There you go. Woo! All right. All right, pass someone, Gio. Mario, go. 1. Hands, have you got that? Okay, we got it, right? All right. And so on and so forth. Okay? That's how you construct a Pascal triangle. Now, why is that so important, Mr. Q? Because Pascal came up with a formula to multiply binomials with high exponents, but without showing the work, just finding a pattern. However, I don't want you to memorize the formula. What I want you to memorize is how to find the product using the Pascal triangle and that pattern, and I'm going to show you that next. But before I go there, look up. I want to clarify some things. Look up. X to the 0 and 2 to the 0. Anything to the 0 exponent is 1. Anything to the 0 exponent is 1. Anything to the 0 exponent is 1. All right. Next, x to the first is x. 2 to the first is 2. So anything to the first power is that same number or variable. Are we there? All right. Now that we have that clear, look where we're going. Don't copy this. Just pay attention. You're like, oh, snap, Q. Oh, yeah, I got you. Look up. Stay focused, because tonight's homework is going to be a doozy. And if you're not paying attention, you're probably not going to get it. I'm just giving you a heads up. Here it goes. So the first two are easy. Find the product. This to the 0 exponent is, everyone, 1. Okay. This to the 1 exponent is x plus y. It's itself, right? This is where it starts getting interesting. This one is the same as x plus y times x plus y. But what are you talking about, Mr. Q? Over the weekend, they made some index cards and they memorized their properties already. So they already know what this is, right? X squared plus 2xy plus y squared. Is that correct? We don't even need to worry about that. And so on and so forth. So that means this one is what? X plus y times x plus y times x plus y. So that means we multiply these, it gives us this, and then we multiply that times that, and it's going to give us a bigger number. Is that correct? So isn't that a lot of work to continue multiplying a lot of these? Because what if I said, find me x plus y to the 6th power? That's a lot of work. Imagine x plus y times 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 x plus y. It's a lot of work. So Pascal found out a pattern of how to do all that work just using a pattern which is a Pascal triangle. So with that said, copy this one please on your paper. Example 1, parentheses x minus 2, close parentheses to the 5th power. parentheses, x minus 2, close parentheses, to the 5th power. Just copy it. I'm going to show you how to do this one, all right? And I'll tell you when to copy what I write. Here it goes. Y'all ready? All right. Write your utensils down. Look up to the screen. Please stay focused. Please, pretty please. Help me help you. Y'all ready? Here it goes. Write your utensils down. Look up to the screen. Step 1. I'm going to create a Pascal triangle up to the 5th row. Tell your neighbor how I know that I'm going up to the 5th row. Tell your neighbor, I'm going up to the 5th row. Who went last? Mario? Mario, pass someone. How do I know that I'm going all the way up to the 5th row according to what I see here? To the power of 5. Yes, this tells us the row. So watch. Look up to the screen. So on the side, I'm going to do 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. And I stop. Why did I stop? Because I need what? Row 5. Are we there? Okay. So now that I have my 5th row, pay attention to this part. Don't write anything down. Wait for me. I'm going to write all this as coefficients. Watch. 1 space plus 10 space. I'm on that. It's 5. Space plus 10 space plus 10 space plus 5 space plus 1. Are we there so far? Okay. So here goes the process one more time. I look at the exponent. I create my triangle to 5th row because that's the exponent. I use those numbers as coefficients. Now here goes the next part. Look up. Term 1. Ready? X to the 5th. Next term. X to the 4th. Next term. X to the X to the X to the X to the second term. Look up. Negative 2 to the 0. Negative 2 to the 1. Negative 2 to the, and so on and so forth. Copy that, please. Woo-wee. Let's go, Caitlin. We got this. All right, here we go. So the process, one more time. First things first, you look at the binomial and the exponent. That tells you which row to stop. I stopped at row what? 5. I got each of those numbers and wrote them 1 space plus 5 space plus 10 space plus 10 space plus 5 space plus 1. Then I started with the first term at the highest exponent, and each term it went down 1. Start with then you go with a second term, and you start with the lowest exponent, and each term you go up 1, all the way up to 5. Are we there so far? All right, writing utensils down, look up to the screen. Here goes the next part. Next, I'm going to simplify each term at a time. Watch. 1 times, what is x to the 5th? X to the 5th. Times, what is negative 2 to the 0? 1 plus 5 times, what is x to the 4th? X to the 4th. What is negative 2 to the 1 power? Negative 2, is that correct? All right. Plus 10 times x to the 3rd is x to the 3rd. What is negative 2 squared? Well, negative 2 times negative 2. What is negative 2 times negative 2? 4. Plus 10 times x to the second. This is negative 2 times negative 2 times negative 2. That is negative 8. Plus 5 x to the first times negative 2. I'm going to write it on top. Negative 2 times negative 2 times negative 2 times negative 2. That gives us 16. Plus 1 times, what is x to the 0? 1 times, what is negative 2 to the 5th? Negative 2 times negative 2 times negative 2 times negative 2 times negative 2, which is negative 32. Copy that, please. Woo. So as you're copying it down, here goes the process one more time. I look at the exponent to see what row I stop on my triangle. There it is. From there, I use this as coefficients. I use the first term starting at exponent 5. Next term, it goes to exponent 4. Next term, exponent 3, 2, 1, all the way to 0. I use the second term to get started on the first one, and it starts with 0 exponent. Next term goes up 1, goes up 1, goes up 1, goes up 1, all the way to 5. The next step, we simplify each term. So 1 times x to the 5th times negative 2 to the 0 is 1. 5 times x to the 4th, negative 2 to the 1st is negative 2, and so on and so forth. Copy that, and then we got one more step and we're done. Last step. The last step, look up, multiply the numbers of each term and bring down the rest of the variables. Here we go. What is 1 times 1? 1 times 1. 1 x to the 5th plus. What is negative 2 times 5? Negative 10, bring down the x to the 4th, put that in parentheses, plus. What is 4 times 10? 40, x to the 3rd, plus. What is negative 8 times 10? Negative 80, in parentheses, x to the 2nd, plus. What is 16 times 5? 80, x to the 1st, plus. What is 1 times 1 times negative 32? Negative 32, and we are done. Copy that, please. Ooh-wee. I took my time with this one to make sure that you got all the components. Everybody with me? And we're going to go a little bit faster on this next one to see how we do with the process. All right? Everybody go like this? Bear with me. Yes? All right? Y'all ready? Everybody done with this? All right, copy this next one on your screen, please. Example 1Q. X minus 3 to the 4th power. X minus 3 to the 4th power. X minus 3 to the 4th power. All right? Tell your neighbor the first thing you're going to do once you see that. X minus 3 to the 4th power. What do? All right, Caesar, what do we do? Fourth row of the Pascal triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and I stop because that's what? Row 4. Hands if you got that. All right, what do we do with these numbers? Tell your neighbor, what do you do with those numbers? Tell your neighbor. Then Rachel's going to enlighten us. What do we do with those numbers? Go, Rachel. Okay, so you write them as coefficients, 1 per term. So we start with 1 space plus 4 space plus 6 space plus 4 space plus 1. All right, We're about to pass this one back to, how about Renzo? What do I do next? First term, which is x to the fourth, and then? Yes. Yes. What do I do next? Tell your neighbor. And then Ashlyn's going to enlighten us with the next part. What do we do next? Tell your neighbor, please. All right. Ashlyn. -3. To the what? To the 0, and then? Yes, and then just consecutively move up 1 all the way to 4. All right? Next, Gabriel, help me out. 1 times x to the 4th times, which is 1 plus 4 times x to the 3rd times -3 plus 6 times -3 times -3 is +9 plus 4 times -3 times -3 times -3. -27 plus 1 times x to the 0 is 1 times -3 times -3 times -3 times -3. Or what is -3 times -3? And -3 times -3? 9 times 9? 81. Woo-wee. And last step, numbers times numbers. What is 1 times 1? 1x to the 4th plus, what is -3 times 4? -12 x to the 3rd. Put that in parentheses. Plus, what is 9 times 6? 54 x to the 2nd. Plus, what is -27 times 4? -108 x to the 1st. Plus, 1 times 1 times 81 is 81. From 1 to 5, how comfortable are you with this? 4s, 5s, 4s, 5s, 3s, okay? We need more practice. We'll do one more. But before I do, let me send you the screen so you can send me your work. I want to see what you're doing. Make sure you're on the right track. Hold on. Send that in, please. All right. Copy this one, example 1, super Q. You should be able to do that one by yourself completely. X plus 2 to the 5th power. X plus 2 to the 5th power. Copy that on your paper. X plus 2 to the 5th power. Go. All right, looks like we're done with this one. Let me see. Help me with this one. Edwin, tell me what to write. What do I do? 5, row 5. Okay, so then I write 1, 1, 1, 1, 2, 1, 1331, 14641, 1510, 1051, and I stop. So then I write each of those as terms. 1 space, 5 space, plus 10 space, plus 10 space, plus 5 space, plus 1. Then what do I do, Edwin? X to the 5th, X to the 4th, X to the 3rd, X to the 2nd, X to the 1st, X 0. And then 2 to the 0, 2 to the 1, 2, 3rd, 4th, and 2 to the 5th. All right. And multiply these out. This is 1 times x to the 5th times 1 plus 5 times x to the 4th times 2, 10 times x to the 3rd times 2 squared is 4 plus 10 times x to the 2nd times 8. Hold on. 5 times x times 16 plus 1 times 32. Answer, 1x to the 5th, 10x to the 4th, plus 40x to the 3rd, plus 80x to the 2nd, plus 80x plus 32. Hands if you got that by yourself. All right, who? Yeah, Caitlin. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye. Whew. This is a doozy, right? Let's go. Kelly, you good?